Okay, so yesterday we were at this point. We wanted to find the intervals of concavity of this function. Okay, so anytime we want to determine the concavity of a function, f, we need to look at what? The second derivative, f prime prime, okay, or the double derivative. Sure, I think that's probably a legitimate way to say it, if you not unique at least. All right, so we had our function, and we were like, oh, Mr. Widd, you're going to give this to us at the very end of class that you're the worst. We took the derivative. Oh, Mr. Meyer, you're not that bad. It combines together pretty nicely. I'm going to take the derivative of that, which we had to use the quotient rule, right? Quotient rule. Simplified it to this. And then to kind of like determine the concavity, we take that second derivative, and what do we do with the second derivative? Set equal to 0, or when it's undefined. It's like finding the critical points all over again. In fact, I don't know if we call those things critical points, but anyway, that's basically the same work. So we set the numerator equal to 0, we set the denominator equal to 0. We to determine the denominator never equals 0, right, because it's going to give us imaginary numbers, and we keep it real in this class. And then the numerator could equal 0 when x is 1/2 or x is -2. So we go to our number line here for the second derivative, or the double derivative, -2 and 1/2, okay? And then we pick numbers in those intervals to then test back in the double derivative, all right? So we also pointed out here, and I forget who did this, that I think it was Caleb. Caleb pointed out that the denominator will always be positive, right? Because you're going to take your number, square it, so that makes it positive, add 1, still positive, squaring it again, still positive. So the denominator will always be positive, so it's not going to affect our second derivative value, sign, I should say, the sign of it. So we really only need to worry about the numerator then. And I'm not going to focus on the numerator as it's written right here. I'm going to focus on like the factored version that we have right here. Okay, actually though, never mind. I want to be careful about that. Never mind. We want to plug it into the numerator here. Let me refactor that numerator though, because I don't like what I did there. So -4x squared minus 6x, and I'll point out what I'm talking about here in just a second. So we'll factor out a -2, which leaves us with the 2x squared plus 3x minus 2. Bless you. So I factored a -2 out of my second derivative's numerator, okay? And then we're going to factor this, and we know that this thing factors to 2x minus 1 and x plus 2 from previous work that we did. Okay. Notice here's that thing that I warned you about, where when we factor out the -2, so for example, when I went up here, okay, when I was doing my work over here, I started with the same exact numerator as I did over here, but then my next step, I divided both sides by 2, right? So dividing out the 2 here yielded -2x squared minus 3x plus 2, and then dividing 0 by 2 is just 2. And then I multiplied both sides by -1, yielding this, okay? And then I factored and left me with this. So now, watch this. If I take this -3 and plug it in here, okay, if I plug it in here where it's factored, okay, plug -3 in, -3 times 2 is -6 minus 1, so this will be what? -6 minus 1 is negative, okay, and then -3 plus 2, negative. So negative times a negative, it looks like this should be positive here. But it's not, because Mr. Whitmire did not plug his number into the second derivative. He plugged it into like part of the second derivative. We should really be careful, because if I plug -3 in here, it'll still be negative, this will still be negative, but there's a -2 in front. So it's negative times negative times negative, which makes overall negative. So what should I put here? A positive, because negative times a negative gives me positive, or should I put negative for this interval because it's negative times negative times negative? Which one do we trust? This one or this one? This one. The red ones. Okay, we have to trust the red one there. It's negative here. Okay? So that's why we have to be very careful. This work we did here is okay because we were setting the derivative equal to 0. So it was okay to say these things are all the same step. Here though, our derivative is not equaling 0. We're trying to like determine what the value is here, whether it's positive or negative. And so I don't want to use this like simplified version of my numerator. I need to go back to the original version of the numerator with that -2 factored out. Okay? So So we have to be very careful here. Have to be very careful, okay? If you want to be safe every single time, just always plug it back into the derivative. Just plug -3 into the x there, the x there, the x there, and just figure out the sign from that, okay? Don't worry about trying to use the factored version if you're concerned about that. Just plug it back in, okay? But the key really is just this. Use the original version. Don't, don't forget about these coefficients that we pull out, okay? Emma, let me explain it here since you just came back in real quick. So, what I was pointing out here is that we're at the point where we're testing numbers in our, testing these numbers. So I wanted to test -3, for example, okay? Plugging -3 in, well, normally we go to like the factored version, right? So like over here, I have a factored version kind of my numerator there. I don't need to worry about the denominator. The denominator will always be positive. It's a quantity squared, so this thing's always positive, so I can kind of ignore it. But this piece, if I plug the -3 in, 2 times -3, -6, -1, -7, so it's negative, okay? And then -3 plus 2 is still negative, so it's a negative times a negative. And so, that makes it positive. But this thing right here is not equal to the numerator of my derivative, right? My numerator, what I did here is I first divided this thing through by 2 and then divided through by -1. That changed my numerator. It was okay for me to do that here because it was equal to 0, but when I do that just to the plain numerator without it, because I'm not setting it equal to 0 here, I want to know what the actual value is, I can't do that. I need to then factor it and then leave that -2 factor out. So this is the factored version you want to plug it back into, not this one. This is simplified because it was equal to 0. This one is the full numerator. So when I do that, it's now got a -2, so it's negative times a negative times a negative. So the overall negative is negative overall. Okay. Sorry about that, guys. That was a little bit crazy. But anyway, let's plug in 0. Okay, so it's going to be negative. 2 times 0 minus 1. Negative, because 2 times 0 is 0, minus 1 is negative. And then 0 plus 2? Positive. So this interval is positive. Negative times negative is positive, times positive is positive. Okay? All right, 1. Negative for the -2. 1 in there. 2 times 1 minus 1? Positive. And 1 plus 2? Positive. So overall, negative. Okay. And so then we are concave up. F is concave up. For what intervals? Go ahead. Negative 2 to 1/2. Very good, Brandon. Exactly right. And how are you able to determine that? Yep, and you can just say because f prime prime, careful, second derivative is not increasing. F prime prime is positive. The first derivative would be increasing on that interval, and that would be a good justification if we were looking at the first derivative here. If the first derivative is increasing, then yes, f is concave up. But more important, f prime prime, I'm going to say that here because you don't have to write the justification, but I'm going to write it just because, we need to be able to justify too. F is concave up on that interval because f prime prime is positive on that interval. Okay? If you want, you can also just write f prime prime greater than 0. You don't have to write is positive. You can just put f prime prime greater than symbol 0. That's okay. Those mathematical symbols mean that thing. Okay? All right, what about when is f concave down? Yep, so negative infinity to -2, union 1/2 to infinity. And again, because why? Yeah, I'm going to use f prime is less than 0 on that interval. Okay. I said, be careful using your symbols, right? Don't use a plus sign for the word positive. Don't use a minus sign for the word negative. You need to write those words out. But here, this is the actual math. F prime prime is less than 0. That is okay to say that. That's what we're trying to say here. Okay? Okay. Questions on that one? That one was pretty intense, but I just wanted to, show you an example of an intense one, I guess. Right? Whatever the intervals of concavity. For that last one we did yesterday. Obviously, you weren't here, but it's the very one at the end. One at the very end.
Okay, so now we're starting with that.
So now, we're getting into then points of inflection.
Yep, I took the last.
Okay, the bold move and just flip over to.
And it's first box.
Bold move.
It's like, them is even better. And it's like, I had home studies first box, but I dropped home studies for one. So it's like, still first box, which is all that over.
Okay, so if.
What are you doing? 101. Cool. Yeah, I think it's like, because we have like 3 to 5 days, we don't have.
Later, yes.
Did you just change that? Well, I've been thinking about it for a while, but yeah.
Okay, if CF of C is a point of inflection of the graph of F, then either F prime prime of that C value is 0, or F prime prime of C is undefined. Okay? This is kind of like that relative extrema, like a relative maximum or relative minimum. If a point is a relative maximum or relative minimum of the graph of F, then either F prime equals 0 or F prime is undefined. Here, a point of inflection, okay, a point is a point of inflection of a graph of F if either that point makes the second derivative equal 0 or that point makes the second derivative, or sorry. If something is a point of inflection, then the second derivative must either equal 0 there or be undefined there. But not every time the second derivative equals 0 or is undefined do we necessarily have a point of inflection. Okay? So just like relative extrema, right? Just because the first derivative equals 0 or is undefined, are we guaranteed to have a relative max or relative min at that point? No, right? It's got to change from negative to positive, positive to negative in the first derivative. Same thing here. A point of inflection, if something's a point of inflection, the second derivative has to be either 0 or undefined at that point, but not every point where the second derivative equals 0 or is undefined will necessarily be a point of inflection. Okay, so how do we know? Once we have our kind of our candidates, once we have our points picked out, so here for example, -2 1/2, those could be points of inflection. How do we know if it is a point of inflection or not? Here we go. A point of inflection occurs when the concavity and I mean, anyone want to take a guess here? It's very similar to the relative extrema. A point of inflection occurs when the concavity, what?
Equals 0. Changes.
So the point of inflection will be equal to 0 or undefined at that point, yes, but when the concavity changes. Just like a relative maximum, right, the function changes from increasing to decreasing, okay? And for a point of inflection, it's where the concavity changes from either concave up to concave down or concave down to concave up. Okay? So a point of inflection occurs when the concavity changes from upward, so concave up to concave down, so from upward to downward,
Or vice versa.
or vice versa, exactly right. Okay. Notice there is no delineation between changing from concave up to concave down or concave down to concave up. A point of inflection occurs at either of those two situations. We don't say like, oh, we call it this kind of thing when it changes from concave down to concave up, and we call it this other kind of thing when it changes from concave up to concave down. Okay, that is different from when we did our first derivative, right? If the first derivative changes from negative to positive, that means we have a what there? Relative minimum. And if the first derivative changes from positive to negative, that means we have a relative what there? Relative maximum. But for a point of inflection, if the second derivative changes from negative to positive or positive to negative,
It's just a point of
it's just a point of inflection, regardless. Okay. So the point of inflection of F occurs when F prime prime changes from negative to positive or vice versa. And it's kind of bothering me because I said concave upward to concave downward here, and then I switched the order, so...
So that's what vice versa is.
Yeah, I know, but still, it bothers me because of the paragraph. I don't want you guys to think...
You could have just said changes and then
Yeah.
stop there.
Yeah.
Avoid the problem.
Okay, so let's see a quick example here. All right, so we want to determine... Actually, I should stop there. Any questions on that so far? Okay, is that very clear? So this is basically like, take the work that we did for the first derivative to find relative extrema, translate that now to the second derivative. It's the same exact work, it's just we're finding something different because it's now the second derivative, not the first derivative. What, yeah, concave up, concave down, I mean, the point of inflection would look like? Sure, in fact, let's take a look at... Okay, so if we, real quick, we'll pause here, okay? So, if we look back here at our original function we talked about yesterday, all right, we were concave up on the interval from 0 to infinity, and we determined we were concave down from negative infinity to 0. So that means where's our point of inflection? At 0. Yeah. At 0, we're changing from concave down from the left to now concave up. So we're like a frown, and then we start to cup. Frown, cup. Frown to cup. Okay? Frown to smile. Frown upside down to smile. Turn that frown upside down. There you go. The cubic does that as you go from left to right.
Except this is calculus. So it's just
always frown. Even when it's a smile, it's a frown. Turn that smile upside down.
You're not allowed.
What is a point of inflection? It just locates the place where the concavity changes. That's it. You can see like what's the meaning of it and stuff like that. I'm having trouble coming up with something. Like the relative maximums, are a very obvious application. The point of inflection less so. But anyway. Oh, by the way, I want to point something else out. Shh. All right, Brandon, real quick. So I can't really answer your question basically. I'm not sure.
Graph where to go up, and then go to 0, and then horizontal across
the second derivative. I see what you're saying. I don't think so because then the second derivative on that other side would be 0, so you can't change from positive to negative there. It would just be.
There wouldn't be a point of inflection.
Yeah, I think so. Yeah. Shh. All right, real quick here, I want to point something else out. Okay, so Brandon very correctly identified that the point of inflection in this graph is 0. Notice what thing. So again, 0 was the point of inflection here. How does that translate? What is 0 in the derivative graph?
Point of origin.
When it changes from decreasing.
Okay, which is also a relative what? Minimum. So a point of inflection in the original function ends up being a relative extrema in the derivative. So here, okay, 0 was a critical number, 0 is a point of inflection. Here, 0 is a relative extrema, okay, for the derivative, okay? So, and there is a relationship there, because both of these things, this 0, the 0 point of inflection here, the 0 relative extrema here, are both using the second derivative, right, to determine them. This point of inflection, because this is the second derivative of f, but then this is a relative extrema because this is the first derivative of f prime. Okay? So anyway. All right. We'll see more about that later. That's a little bit confusing. Anyway. Determine the points of inflection. And discuss the concavity. Of the graph of f of x equals x to the 5th minus 5x to the 4th plus 4. Okay? Doggone it. That's what happens. Dis us. Okay.
What?
So, Joey, to discuss the concavity of a function, what do we need to find? The double derivative. Very good. All right, and to find the double derivative, we first have to find the single derivative. Okay, so f prime equals. That's right. All right, so Joey, what would that single derivative be?
5x to the fourth.
5x to the fourth.
20x to the third.
And that's it. Very good. That's right. Yeah. All right, and then what's the double derivative there, Joey?
20x to the third.
Minus
60x to the second.
60x squared. Very good. All right. Thank you, Joey. All right. At this point, Brittany, now what? Because your number came up. Your number is 4, by the way. Set the what equal to 0? Second derivative. Yep, equal to 0. Exactly right. I just want to make sure, because again, those pronouns are tricky. So I just want to make sure you're talking about the right thing. I don't want to ever assume. All right, and then, Brittany, we add 60 squared over and divide both sides by x squared? No, Mr. Whitmire. What do we do? Yes. Factor out 20x squared. We're left with x minus 3. Okay, so that means either x is 3, that's a possible point of inflection, or x is 0 is a possible point of inflection, right? Okay, great. Thank you, Brittany. All right, Tyler. Now what? Well, I took the derivative, set equal to 0. I did that. I already came up with the answers right there. I jumped ahead there, just because it was pretty easy to do that one and that one. So now that we have these possible points of inflection, what should we do with those? Right, very good that we checked that. Yep, can't make it undefined. Yep, exactly right, the number line. Okay, so 0's first numerically, so we put 0 to the left of the 3, taking this in f prime prime. And so pick some numbers there in the interval for us, Tyler. F prime prime of 1 here? Oh, okay, F prime prime of 1?
-1, 1.
Okay. Those sound good to me.
I was thinking we would do negative pi e
Alright, so -1, we're going to plug that in. Now, is it okay if I plug it in this one right here?
Heck yeah.
Yes, I have not adjusted it, right? This is all just factored straight from the original, right? I just took out the 20x squared, nothing, I didn't like divide both sides by something to cancel it out, okay? So that's all the original derivative right there. So I can plug it in. Now the good thing is, 20x squared will always be what? Positive. So I only need to worry about this x minus 3. So -1 minus 3 is? Negative. 1 minus 3 is? Ooh, it didn't alternate.
Uh-oh.
Okay, so be careful. Right.
You got a problem.
And then 4, positive.
So 0 isn't one of the
So 90% of the time, it will alternate. In this case, it did not. Okay, it did not. So we have a point of inflection. Christian, where do we have a point of inflection?
At x equals 3.
At x equals 3.
Just x.
Oh, just x equals 3. Why only x equals 3?
Because at x equals 0, nothing actually changes.
Okay, f prime prime does not change, right? So I'm going to put my justification here again. It didn't ask us to justify, but I'm going to do it here for your sakes, for your practice. You need to see this, and maybe I would suggest write it down too. Point of inflection at x equals 3 because f prime prime changes from negative to positive at this point. Okay. You only need to write the justification if it says justify. But it didn't say justify here, but I'm putting it in. I'll put it in parentheses maybe, so that way you know it's like not necessary, right? There can be more than one point of inflection, but you understand why 0 is not a point of inflection. Okay. Yes, but you can have more than one. Absolutely, you can have however many not how many you want, but I mean, yeah, you can have more than one. Okay. So F is concave up. He's sick, guys. He has to rest. All right. Oh, he's awake. He's alive. You're talking about me. I guess I'll wake up now. All right. F is concave up for what interval here?
Ask Caleb.
Someone else. Emma. 3. F is concave up from 3 to what? Infinity.
What about beyond?
I don't know about beyond infinity.
Really? So there's infinity. Infinity's got a number at the top.
Okay, so F is concave down. Emma? You can say negative infinity to 3. I think it's okay, but because it's like at 0 there, I'm unsure. I'm going to break it up, and that's okay to break it up too. Okay? I think you would be okay at 0, but I think breaking up is probably the better idea. So negative infinity to 0, 0 to 3, like that. I think it is okay. I think it is okay to go through those points because immediately to the left, immediately to the right is 0. It's concave down. But if you want to be if you don't have to worry about it, just always break up the interval. Even if they have the same, even if they're right next to each other, just break it up. You'll be fine. Okay. All right. Here's one for you to try.
Yes.
C, señorita. McSweeney. C. Okay, here we go. Find.
Never mind, we can't.
My hand was in the way. Find the points of inflection. Point of inflection. Of G given G prime of X equals X times the square root of X plus 1. Okay, which, obviously the same thing as X times X plus 1 to the what power? 1/2, yeah. Okay, now, be careful here. I changed up a little bit of the original information, so please don't just go into autopilot, read what you've got, and then think about, okay, since I have this, now I need to do this. Okay, so don't just go into autopilot. Okay. I helped you out, though, right?
Indeed you did.
Right. No, and I did that. Say one more time, sorry. Plus G prime. You can do it that way. So, because
it matters for the quotient rule.
It matters for the quotient rule. The order does, right? It does not matter for product rule. You can do F prime as long as you can do F prime times G plus G prime times F, or you can do F times G prime plus G times F prime. I always do it the same way every time, Max. That way
Are you gonna simplify it? Or are you
don't get it mixed up for the quotient rule. Another question?
I'll do some.
Excellent.
Well, yeah.
Yes, good.
Is that cancel out
Which one to factor out? What power to factor out? So it's again,
No.
when you come across something that's difficult,
Yeah.
okay, like that, and you're unsure, try to come up with something that's like that, but simpler. So let's not worry about
Or
negative
you
positives.
just
Let's just
take
worry
what
about
there
like
is now.
x to the 4th plus x squared. If I have something very simple like this, you know what to factor out here. What do we factor out? X squared, okay? If I have like x to the 9th plus x to the 5th, what do you factor out here? So we're limited by the lower of the two powers to what we can factor out, right?
I would factor out a negative.
You would factor out, yeah, x plus 1 to the negative 1/2.
What would be?
Okay, good question. So then what is the result?
I don't know why.
Well,
This-
for the term that has x plus 1 to the negative 1/2, that's easy to factor out. It's just, you know, it just
Yeah.
divides out, okay? But you have then x plus 1 to the 1/2, and you're trying to factor out negative 1/2, x plus 1 to the negative 1/2 out of that. Remember, factoring is dividing it out. It's dividing it out, right? When you had like x to the 9th plus x to the 5th, when you factor that x to the 5th, you're left with the plus 1 there, and that would be x to the 4th. You divide it out, x to the 5th. So dividing out, well, you have the same base. What do you do with your exponents? You divide what you do with your exponents. When I had x to the 9th and I divided out x to the 5th, it became x to the 4th. What did I do?
You divide it, but like.
That's why he
I
said you
divide
gotta
them.
read it first.
You gotta set it up like actual like division, like, and then when I just flip the,
What, okay, I don't think you see what my point was here. So when I factored out x to the 5th here, that left me with 1. When I divided out x to the 5th, from x to the 9th, what do you do to your exponents to get 4? Subtract them. So you have, all you have to do is do 1/2 minus negative 1/2, which becomes 1. 1/2 minus the negative 1/2. And so what you're left with is then something actually more, kind of more than what you started with. So, okay.
Like they're left with x plus 1.
To the 1, yeah. Which is just x plus 1 question. Right? That's the beauty of these, how these simplify sometimes.
Is this the second derivative?
Let me get my thing here. Yeah, that was good.
Yeah, I just didn't factor out the two.
Yeah, that's okay.
When you take out negative 1/2, you get.
So when you factor out x plus 1 to the negative 1/2,
Put X on it.
you're really dividing, right? So you have the same base. What do you do with your exponents when you divide? When you divide two numbers at the same base and different exponents, how do you simplify it? What do you do with the exponents? What's x to the 9th divided by x to the 5th?
No.
What's x to the 9th divided by x to the 5th? How'd you do that? What's 1/2 minus negative 1/2? It's 1. So that's what it simplifies to. It's just plain old 1. Other questions? Jack, you have a question? All right, right there, Mac, 1 second.
I like don't know what you're asking,
Then,
Yes, and that's, you didn't quite trip on. So let me ask you your homework. So, so now your first step starts off with that.
I'm so confused. I need to just write it.
Would you guys do?
Right, how do you undo the 1/2? What should you do? What's the opposite to the 1/2? Square root. That's right. X plus 1 then equals 0. I'm solving for x. X is negative 1.
Yeah. What else is on
Yes. No, there was a plus sign between the two, right? Oh, wait, I see what you're saying. I'm sorry, hang on.
Negative 1 and negative 2.
You can't factor out 1/2 x here because both terms don't have 1/2
No, I
x.
didn't, I factored it there.
Oh, so that should be 1/2 x plus x plus 1.
Oh, I got it.
So a little plus sign between those two. And so then, yeah, combine like terms, set that equals 0, set that equals 0. If you want, you can write it as a fraction, right? That negative exponent brings it down to the denominator.
Ooh, I'm thinking my road. What should I write for my job description for Pump It Up? got my gas.
Doesn't sound really fair.
I think, you know, I think,
Supervise
but I think
children,
it has to be like the way,
provide customer service.
because like, tab is like always over the interval. I guess you can know, I don't know. Yeah, you should break it up. I mean, that's my, the end point is like, yeah, break it up. Don't, I would always break my notes. I think you take away sometimes, including it, but I'm not sure exactly what the times are. So I broke it up, that's what I'm saying. I think that I can always break over.
I'm not. Yes, those are the correct possible points of inflection. All right, let me, I think,
Over here, and I'll be right back.
Are we sending this?
So I would complete this one half x plus one x. So one half plus one, that's three halves x.
Oh, this for
And then this has negative x on the denominator, which is all over. This is positive.
Right people
Now I think you'll see what's more clear about what you studied. Yeah. So yeah. Okay, what's up?
I think mine is pretty good. I just use the Google Docs template.
Oh, well,
I still need to finish my letter.
Yes, it would be the negative 3 because that's the smaller one, exactly right. And then the other one would have a to the first power, like the one that was originally -2, and the other one's -3. You subtract out the -3. The original first one will have a positive 1 power.
Can I see my quiz with I have a lot of it.
I like road I didn't want to embarrass it because I was
It's X plus 1 to 1/2.
but at the same time, like, it was all.
I got a 1 out of 2.
Okay, so I know so this is like, just you're not pushing for one still, but I still see like.
Make sure
I see like
when you
ideas.
go like go on your computer and make sure it's not over a page.
It's not.
Okay. You just like
Yeah, you got.
not want your resume to be over a page, especially like when you're in high school. You don't want to resume.
It's also like farming.
Well, actually, no, to undo it by half, square both sides. So what you do is just 1 half. Because 1 half is a square root, that is the
I got a 92 and a half.
So to undo square root, you square both sides.
I hate scripting.
Yeah.
You don't have the defroster?
Well, I have a problem.
I have one in the front of the and I have a heated steering wheel and heated seat.
I do not have.
okay.
It's actually really nice. But like where the seams are, where like the leather stitch, it gets really cold just on the seams, but the heating element doesn't go there. Hashtag personal problems.
Anyone still, anyone, any other questions here? We're gonna go over in just a second. Questions?
The dashboard where he comes up first.
Yeah, and it has good steering. It's kind of nice. I mean, at a point it's like super hot, so I was actually use it.
You're like,
Yeah, well mine has like 2 different levels for the mine.
One more minute here, folks, one more minute. -1 and -2/3 are your possible,
same problem.
are your possible points of inflection. You, when you're checking the intervals, Emma, yes, you're plugging it back into the second
I
derivative.
had the -1. I didn't get the negative.
I keep this with the
What point did you use between -1 and -2/3? It can't be -1/2.
Negative
No.
2/3 is 0.2.
Did you have to distribute?
Well, yeah, I mean it can.
What's my point?
I use -3/4.
So,
-1/2 won't work.
it should be 1/2 x plus 1, no plus 1 here. When you factor this out, right? This little thing that's left over is 1 half x. Plus, what's left over from here, the x plus 1. This plus 1, there is no plus 1 here. See what I'm saying? So you have 2 terms. So when you factor out the x plus 1, you're going to end up with 2 terms in the parentheses. What's left over from here, the 1 half x. Plus, what's left over from here, x plus 1. So plus 1 should be there.
I haven't had, I was thinking about that, but I haven't had him in
This isn't here.
Correct. And then a big plus sign between those two. There you go.
I mean, not that like it was bad, I just like,
Wow.
All right, folks, just in the interest of time, I want to make sure we can get through this here, so there it is. Okay, pre-prepared example.
yeah. Got it right.
Well, we need to.
Notice, yeah, I know. Notice the interval to the left of -1 does not exist. Because when you plug the 2 in here, -2 plus 1 is negative. Square root of a negative, imaginary. Okay? And that's going to hold true even the original function here. When you plug anything less than -1 in, you're going to get imaginary. So that interval does not exist. Okay? If we go to the graph here, just kind of see that at work. Okay, there it is. -1 is where it starts. Concave down for a little bit and then concave up at -2/3. It's very, very subtle. You can kind of see the very subtle concave down there and then suddenly concave up. And it goes on forever after -2/3. So,
How would -2 be negative? Because
when you plug it in the second derivative, -2 plus 1 is -1. Square root of that, imaginary. Right? So yeah.
Oh, that's right.
Yeah. All right, you guys ready for your homework? No?
Yeah.
Here.
Yesterday I went here, so they had
Sure, I can remind you again. No, don't remind again.
I thought they would have done some, because, you know, I was laying in bed crying, like, not like crying, but like laying in bed, like hurting yesterday. And they're telling me that ours is almost completely finished. Yeah, I need ours.
4 problems, folks, there it is.
Weak. I was right.
Yeah, Brittany is ours.
Okay.
I'm sick. I'm gonna read through it and like make sure that. I mean,
Hey, Mr. Wood. End communication.